Hey everybody, this is a little video to help you out with the practice problems for your geometric series. So I thought I would do the odds with you just for a little bit more of an explanation if you need it. I've written down the formula I'm using for a geometric series, and that comes right off of your SOL formula sheet as well as your notes. So let's look at what we need here. Number one, the directions here tell us find the indicated sum for each geometric series. So I know this is not an infinite geometric series because it's telling me to find the sum up through 12 terms. So in my formula, I know the n value is going to equal 12. Other things I need in the formula are the A1 value, very clearly, that is 2. And then the last thing I need in the formula is the common ratio. So I need to think, what's happening to get from 2 to 6, or 6 to 18, or 18 to 54? Well, for each of these being a geometric series, I'm multiplying by 3. So that makes my R value 3. So by the time I get here, I'm ready to plug everything into the formula. I'm trying to find the series total for 12 terms. The original term is a 2. My common ratio is 3. N value is 12. And again, common ratio is 3. So I'm just plugging each value into its location on the formula. And from here, I highly suggest being very confident at Desmos. I feel like my teaching video showed you how to input all this into Desmos, but if you're having any problems with that, ask somebody. You should get a final summation of 531,440 if you're plugging that in correctly. Okay. All right, let's go down to number 3. I'll do the odds with you, and that'll give you a chance to try the evens. Okay, so let's come up with everything we need to plug in. We need an n value. This problem is saying find 7 terms, the sum of 7 terms, so my n is 7. The first term in the sequence is 10, and now I need a ratio, a common ratio. So what's happening as this series continues to get from 10 to 1, or 1 to 1/10, or 1/10 to 100? I am dividing by 10 each time. So my common ratio is 1/10. Dividing by 10 is the same as multiplying by 1/10. Okay, so now I'm ready to plug everything in. The series of 7 terms here is going to be 10 times 1 minus 1/10 to the power of 7 all over. Oh, I need to put my parenthesis out here. 1 minus 1/10. It's very important where those parentheses go. That 7 is the power on the 1/10. Okay, so if I take this on over into Desmos, be careful of where you put everything. Okay, be really careful. Add another parenthesis around these fractions if you feel like you need it. Should be getting 11.1 repeating. Okay, number 5 is a little bit tricky, okay, because number 5 tells you all of the terms in the sequence. Of course, we're missing a few in there. It tells us the first term and the last term, so we don't know how many terms are in this sequence, which means we don't know our n value. So let me jot this formula down. This will help us find our n value. This is our geometric sequence formula. This is what can build the geometric sequence, and this comes off your formula sheet. So I know the value of the very last term, and I know the value of the very first term. I also can find my R value. What do you have to do to get from -1 to -6, or -6 to -36? Well, we're multiplying by 6, so the R value here is a 6. And we are trying to solve for n. Now this is going to take logarithms. So if that's a skill that you haven't learned yet, maybe we're not ready for this level of problem, but let's solve this out. First things, I need to divide by -1. To get rid of this base of a 6, I would need to apply a log of base 6 to both sides. That logarithm cancels out the base of 6. And here's where I would probably need to go over to Desmos to figure out what is log base 6 of 7,776. Let's go get that. Logarithm is under the functions button, second row from the bottom, and here I'm doing a log base 6, 7,776. I get 5. Log base 6 of 7,776 is 5. So I can replace that out. And then finally, to solve for n, I would add 1 to both sides, and I get an n equal to 6. Okay, so that was pretty challenging. You have to have an understanding of logarithms in order to solve for that n value. Now I can take this information and plug it into my series formula. My A1 value is -1. We found an R value of 6 and an N value of 6. So I guess I could make this S sub 6, the first 6 terms added together. Okay, so that's something else to take over into a calculator to help you with. Nobody is expecting you to know what 6 to the power of 6 is. Okay, if you get this in the calculator correctly, you should get a final sum of -9,331. So be careful in your calculator. Pause the video if you need to so you can get in there and really try to input that correctly, because you wouldn't want a calculator issue to be what keeps you from getting these problems right. All right, a couple summation problems here. I'll do one where we use the formula, and then I'll do one on Desmos with the summation notation, okay? So with the formula, I still need the first term, the R value, and the N value, okay? So using my my sequence notation, I have a R value of -4 right here. And it looks like I have an N value of 12. I'm looking for the first 12 terms. Now my A value is kind of hiding. Remember, my A sub 1 is what's in front of the R value, so there is a 1 times sitting right there. It's just invisible because when we multiply by 1, we just understand it's there. So everything is sitting here for me to find, and then I just take it from there and I plug it into the formula. So the first 12 terms of this sequence would plug in like this. There's my A sub 1 value of 1, then 1 minus the R value raised to the N value all over 1 minus the R value. Okay, so everything fits nicely in the formula there. I can take all of this input over into a calculator that can handle it. You should get a final sum of negative negative 3,355,443. I know that's a lot of work. I like this formula. I like understanding all the parts and how they fit together. I also want you to be really confident using your sigma notation in Desmos. I'm going to do that with you. Sigma notation is under the functions button, bottom row, middle column. The problem we just did uses x as a variable, so I'm swapping out n for x. And then I'm just inputting my lower and upper number and typing in the function exactly how it was given to me. Now when you write in the exponent, a lot of students get frustrated here. You just have to put that x minus 1 in parentheses. Voila, you'll get the same answer we got by using the formula. It's really handy, okay? Let's work this final example problem here, number 9, just using our sigma notation. So I'm just going to stay on this screen. You can look at your worksheet. We've got the summation from 4 to 24. Now our variable here is k, so I'm swapping that out for k. 4 to 14. Okay, now right here, we gotta be careful because we need to make sure that k minus 1 is part of the exponent for the fraction. So I'm gonna put parentheses around k minus 1 so that it's the exponent of the fraction. And so we can get our final summation, negative 2030 I guess we'll say 0.6. There's no directions here on how far to round to. You guys, if you choose to do this on Desmos, you need to make a note that you did that on Desmos, okay? And I don't know, it might even be a good idea to save those files. Have you ever done that on Desmos? You just go over to the, go up here to the menu bar, and instead of an untitled graph, you could title this geometric series, something like that, geometric series practice. Oh, I'm not logged in. Make sure you're logged in when you do that, and then you can title it and save it, okay? Okay, I'll make one more video for the back of this practice sheet, which is the geometric infinite series. So happy studying. Try the evens. Get your work checked with the answer key, and happy studying.